When you think of algebra, I hope you think variables, equations, expressions. Tell me what a variable is. Okay, so it's like a letter. You're right. Why do we use a letter?
It could be like that.
It could be that it equals something, that it can change its value, right? So a variable is a letter that we use. We'll make this a good definition here. Let's see. A letter we use to represent a value. And that value can change. It can vary. That's why we call it a variable. What variable are you probably most familiar with? X and Y, right? Those change. So when we put numbers and variables together, they make up what we call an algebraic, yes, somebody said it, expression. Okay, so that's when we have these variables and maybe they have some numbers hooked with them. There's no equal sign, okay? Expressions don't have an equal sign. So we have variables, numbers, and I'll even say operations because maybe we add, subtract, multiply, divide, all that good stuff within an algebraic expression. I'm going to stop and give you a second to copy, and then we'll do somebody, anybody, give me an example of an algebraic expression.
Oh,
Why? Guys, give me an example of an algebraic expression. 3x plus b. That is definitely an algebraic expression. Good job. It has numbers, variables, operations, right? Tell me what this means. What does it mean when I say 3x?
3 times whatever x is a number.
If I put this in words, this means 3 times x plus b. And I can put any value that I need to in for x and any value I need to in for b. Give me another example of an algebraic expression. X plus what? 3. That is an algebraic expression. X plus 3. It literally means x plus 3. How about is that an algebraic expression?
No.
Yeah, it is.
Because it's 5.
5 times x here, guys. Remember when there's no operation indicated like this and they're just beside, that means to multiply. So I am doing something there, multiplying. So this is really 5 times x. Is anybody confused at this point? Okay, so let's do this. Let's evaluate some expressions. Let's say, I'm going to call this evaluating expressions. Let's say I give you an expression, okay? And we'll even use one of the ones that we just came up with. We'll do the 5x first because it was kind of easy. What if I asked you to evaluate when x equals 2? Tell me what that means.
Oh, you got to 5 times 2.
When I say evaluate when the variable equals something, all I am doing is plugging in that value, okay? So evaluating expressions is just simply plugging in for variables. And so you all said, oh, that's 5 times 2, and you're absolutely right. So when x equals 2, that expression equals 10. Sure. All right, let me define first a variable. Let me say I told you, let's use a different variable. Let's use k. What if I told you, and I'm kind of trying to set these up the way your homework's going to be too, so you'll understand. Evaluate the following, yes, expressions when k equals 5. Okay? And I'm going to define several algebraic expressions that we're going to go through and use and find what they equal when k is 5. So what I would like for you to do is to take a minute and copy this down and try it on your own before we go over it. Remember, think through it first. If you get stuck, look back at your notes and then talk about it with your pod before you get exasperated, okay? So let me just define several here. That's 15 divided by k. So yeah, because that's a All right, there you go. So what we're doing is we're plugging the value of k into each expression. So we are replacing k with 5 each time because that's how it is defined here. So for the first one, the 15 is still there, but the k is getting replaced with. So what is 15 over 5? Which is 3.
Well, I got 3 over.
That's fine, same thing. Same thing.
Okay, good.
Look at number 2. If we replace k with 5,
Equals 2.
we get 2. And then for number 3, if we replace the k with 5, 13. Good job, guys. How many of you got all 3 right? Yay! Give yourself a little pat on the back. Tell me, what is an exponent?
The things that's at the top on them.
All right, tell me again, what is an exponent? A lot. I think you're thinking exactly right. Let me give it to you like this. Which one is the exponent? The 2. This is the exponent. What is the 5 called? Good job.
The base.
The base. Now tell me this, because several of you were trying to get this out whenever I asked you what an exponent was. What does an exponent tell us to do?
It's times the base, but it's many times.
That's exactly right.
Yeah, oh my God.
Multiply the base together this many times. So if that exponent was a 10, then it would be 5 times 5 times 5 times 5 times 5, 10 times, right? But in this case, it's a 2, which means 2 times. 5 times 5, which is 25. Just a second. We've been talking a lot about giving it to me in words, and I'm hoping by giving it to you, by you interpreting this in words, it's going to help us set up for some word problems and stuff. So we'll just go backwards with word problems. How would you say this in words?
5 times 2.
That's what I was looking for.
5 to the second power.
5 to the second, guys, stay focused. 5 to the second power, because sometimes exponents are also called powers. I asked you to evaluate the following. Let's do this. First of all, before you evaluate it, tell me what that means. Give it to me in words. 2 to the fourth power. And it means we do what? Say, that's exactly right. It means we're going to do 2 times 2 times 2 times 2. There's 1, 2, 3, 4 times, right? And I picked a small base here, hoping you could do this without a calculator. Let's move, since it's just multiplication, let's move left to right.
It's 8.
It's 8. 2 times, no.
No, it's 16.
Yeah, I was like, that's a little low for me.
All right, look. 2 times 2 is
That's 4.
4. And 4 times 2 is,
That's how I
8.
do it.
and then 8 times 2 is,
16, Tiger.
I think, and I hope I'm not wrong, that we all understand how to evaluate exponents given this way. Okay? But what if I change it to an algebraic expression? Because an exponent is an operation, do we agree?
Yeah.
And we said algebraic expressions are numbers, variables, and operations, right? So what if I gave you x to the third, and then I said, take that x to the third and evaluate. What does evaluate mean in this case? I'm going to do what? Solve it, simplify it, plug in, right? Evaluate when x equals 3. Got the equal sign. What does that mean to do? Exactly. 3 to the third power, which you're absolutely right, means 3 times 3 times 3. 3 times 3 is
9.
9.
27.
And 9 times 3 is 27. You're absolutely right. And I'm intentionally going left to right with y'all because as we get in, tomorrow we'll get into PEMDAS and the order, but whenever we're doing the same thing, we always want to move left to right, just the same way you read. How about this same one? So let's say x equals 3. What if I asked you to evaluate when x equals 1/2? We're still doing the exact same thing. You're right. You're right. 1/2 to the 3.
Oh, it's like 1/2.
Exactly. Don't make it harder than it is. It's still 3 times 1/2 times 1/2.
Fractions throw me off.
Don't let them throw you. They only they're intimidating to look at, but they're really not hard to work with once you get used to them. Well, you're not adding them, you're multiplying. So remember we did that little review on our fractions? When you multiply fractions, it's top times top, it's straight across exactly, and bottom times bottom. So 1 times 1 times 1 is?
1.
And 2 times 2 times 2?
8.
Look at y'all. Go ahead.